Nasram, I'm here to give a short online tutorial on IUPAC nomenclature of organic chemistry. IUPAC nomenclature of organic chemistry specifically deals with the naming of various organic compounds. And here we are going to see how we can name more than 16 different organic functional groups respectively, and how you can name it, how you can pronounce names in case of JAM, in case of WIC or NECO or A level, maybe universities 400 level. Up to final year, which is 400 level, also in master levels, as the case may be. So, if we will, let's just start with alkene. Alkene. The alkene from the name I-A-N-E. The first member is methane. The second member is ethane. The third member is propane. The fourth member is butane. The fifth member is pentane. The sixth member is hexane. The seventh member is octane. The eighth member is octane. The ninth member is nonane. And the 10th member is what we call decane. So this for alkene. When we talk about alkene with E-N-E, you just remove A and replace it with E, meaning we have what? But remember, the first member did not exist in alkene. No first member, methane. It started with what? Ethane. It's going to be what? E. Remove A and put E. E-N-E. Ethene. We have what? Same thing. Propane. We have the same thing. Butane. The same thing. Pentane. The same thing. Hexane. The same thing. Heptane. That's all up to that. When we're talking about the last one, which is alkyne, remove the same thing. Remove all these and replace with Y-N-E, which is what? Ethane. Then we have what? Propine. Then we have what? Butane. Then we have what? Pentane, as the case may be. So let's now see how do they look like. Automatically, if you are given CH3, CH2, CH2, CH3, count 1, 2, 3, 4. If it's 4, automatically you call it butane because it's under family of alkene. But if you have the CH3, CH double bonded, CH3, this one is a family of alkene and you call it butene. Or you say count 1, 2, 3, 4. You call it butene, as the case may be. Let's assume under here we have the CH3, we have C, we have Cl, double bonded with what? Under Cl, we have what? CH3. How do you call this? To call this, you count 1, 2, 3, 4. And we have attachment at carbon 2 and carbon 3. So what you are going to say is, you call the attachment first. It's going to be what now? 2, 3. If the attachment is 1, there's no need for you putting anything. It's supposed to be mono, but we are silent in there. We're supposed to be, forget about the mono, but we have di if it's 2. We have the tri if it's 3. We have the tetra if it's 4. So this one now will be what now? 2, 3, di. What attach? Chloro. And what is it? 1, 2, 3, 4. If it's 4, you call it butene. Or you said 2, 3, dichloro butene, as the case may be. That's how you name, as the case may be. If you have the same thing, let's assume we remove the H, Cl, we put CH3, we have CH3. This one, when you have the CH3, is called methyl. So if you want to call, you say 1, 2, dimethyl butene, or 1, 2, dimethyl butene, as the case may be. Let me call it right. 1, 3, this 2, 3, dimethyl butene. 2-butene or 2,3-dimethyl butene, as the case may be. We are not done with this. We proceed to the family of alkyne. An alkyne is a triple bond. If you have the CH triple bonded with the CH, this one is called ethyne. And if you have the CH, now if you have C, we have the Br, double bonded, we have Cl. How do you call this? To call this is chloro and this is bromo. You will call alphabetical order B before C. So you don't say 1 chloro, 2 bromo is drunk. You call alphabetical order. You call from the bromine first because it's B. Why chloro is C? You call B before C. So to call this is going to be, you said 1 bromo, 2 chloro, ethyne. 1 chloro, 2 chloro, 1 bromo, 2 chloro, ethyne. Or you said bromo, chloro, ethyne, as the case may be. In a nutshell, I'm done with this. I can digress to the alcohol or alcohol. When we say alcanol, the alcanol, we're talking about a functional group that consists of what? OH. And based on this, we have the primary alcohol, secondary alcohol, and tertiary alcohol. What is primary alcohol? The primary alcohol is the types of alcohol that has one alkyl group attached to the carbon atoms that is bearing hydroxy group. Tertiary, secondary alcohol. The secondary alcohol is types of alcohol that have 2 alkyl group attached to the carbon atom that bears the OH group. When we have tertiary alcohol, these are alcohol that have 3 alkyl group attached to the carbon atom that bear OH. What am I saying from this definition? Let me explain now using the structure. When you have RCOH, this is primary. Why? Because it has one alkyl group attached to the carbon atom that bears the OH group. That's primary. When you say secondary is the types of alcohol that has 2 alkyl group attached to the carbon atoms that bears the OH group or this group. And we say tertiary. The tertiary alcohol, this is alcohol that has 3 alkyl group attached to the carbon atoms that bear OH group. The primary alcohol have 1 alkyl group. The secondary alcohol have 2 alkyl group, and the tertiary alcohol have 3 alkyl group, as the case may be. And this one is called R. To name this is R. For instance, if you have CH3, CH2OH, this is the most commonest forms of alcohol, and it's called ethanol. Why? You call it ethanol from the name E, from the ethane. Remove E and replace it with OL. We call it ethanol. If you have the CH3, CH2, CH2 with OH, this one, normally, if you have 3 carbon, we call it propane. Remove the E, attach OL. We have propanol. If you have the CH3, CH2, 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 OH, we call it butane. Remove the E and add OL. We call it butanol, as the case may be. So this is how to name them. And how are we going to how are we doing in primary, secondary, and tertiary alcohol? Let's assume we have the compound like this. We have OH group, we have the CH3, we have the H, we have the HH, then we have H, we have HH. Automatically, don't start counting from here, it's wrong. You start counting from here. Why? Because we value the functional group. Start counting where you have a functional group. You have 1, 2, 3. If it's carbon 1, 2, 3, so you call the attachment first. And what is the position of attachment? Is 2. What is the name of the attachment? Methyl. To call it now, it's going to be 2-methyl. You now call the parent name. 1, 2, 3. 3 is propanol. So calling the attachment, the first thing you do for you to call the attachment, you name what is the carbon where you find the attachment. What is the attachment? At carbon 2. What is attachment? We have methyl. So is what? 2-methyl propanol, as the case may be. And this is what? Is it primary, secondary, or tertiary alcohol? Automatically it's secondary alcohol. Why? Because it contains of 2 alkyl group, Ca3, Ca3. Let's now digress and talk about tertiary alcohol. Tertiary alcohol, it must have 3 alkyl groups. We have the CH, the CH, the CH. Here is the CH3. Then here we have the CH3. Here is H. 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 And here is OH. Let me just make it complicated. If you have Br here, and I have Br here, and I have Cl here, and I have I here, and I have F here. Automatically, this is tertiary alcohol. Okay, it's not tertiary, this is primary alcohol. But if I do like this, we have OH, we have the H. I think this is tertiary alcohol. This is 1Ca3. No, it's not. This is not tertiary alcohol. Why is not tertiary alcohol? Because we have not have the Ca3. This is not tertiary alcohol. For it to have tertiary alcohol, it must have 3 Ca3. And remember, this is CH2. So you cannot call it tertiary alcohol. So for you to say you want to call tertiary alcohol, we are going to attach the Ca3 here. So we have H here. If you observe, this is 1Ca3 alkyl group, this is one alkyl group, this is one alkyl group. This is satisfied to be a tertiary alcohol. But there is attachment. How do you call this attachment? We have bromine and we have iodo. So you want to name, you start counting 1, 2, 3. If you want to count, then you have B and you have I. Automatically you call B before I. So what I'm going to do, you said 1, because it's carbon 1. 1 bromo, that's satisfied, number 1. 1 iodo, 1 iodo, that's 1 bromo, comma, 1 iodo, At carbon 2, there is 2 attachment, which is methyl. It's going to be now 2, because it's carbon 2, 2 dimethyl propanol. That's how to call it. 1 bromo, 1 iodo, 2 dimethyl propanol. And this is satisfied to be tertiary alcohol, as the case may be. I think I've digressed into talking about the alkanes, how to name alkane, and how to name alkyne, how to name it. I also proceed to talk about alkanol, types of alkanol, what makes them to be types of alkanol. We talked about their even naming and the various naming of them. So now let's now talk about there are some specific reactions. What are the reactions? We have what they call esterification reactions. Esterification reaction is defined as a reaction which specifically occur under reversible reactions, where alkanoic acid reacts with alkanol to form esters and water is given as a byproduct. For instance, if you have esterification, it's named after a scientist that talks about it. Esterification. Esterification is defined as a phenomenon where alkanoic acid reacts with alkanol under irreversible reactions to give pleasant substances, which is called ether, which is called esters, as well as water is given as byproduct. For instance, if we have the RCOOH plus ROH, then you have under irreversible reaction, this is alkanoic acid and this is alcohol. How do you form this reaction? How would the reaction be formed? What happens is this: you are going to remove OH here, bring it down, you have OH minus. You are going to remove one hydrogen here, bring it down, you have H plus. What you have here is RCOO minus. This is minus, this one will be R plus. You will join plus with minus. When you join this with this, automatically what you expect to have water is formed. But when you join this, you start writing this, which is what? RCOO. RCOO. You not join with this. Yeah, if you like, put this prime here. which is RCOOR, and this is called ester, and this is what? Water, and the above reaction is called esterification reaction. It's called under reversible reaction. Let me now give you an example of one. If you have CH3 COOH, this one is called ethanoic acid plus CH3 CH2OH plus ethanol. Under a reversible reaction, you do the same thing. Remove this one to form OH, remove this one to form H plus. This will react with this to form water. Then this one will join with this. We have the CH3 COO. Don't join it with CH3. You start with CH2, CH2, then CH3. And the name of this reaction is called, if you want to call this, you name this first. This one is called ethyl, and this one is called ethanoids. Ethanoids. So how do you call it? It's called ethyl ethanoids, and this is ester, and water is formed as a byproduct. And the name of the reaction is called esterification reaction. Also, there's something that is very, very important under this alcohol, which is the formation of alcohol. How does alcohol formulate? Alcohol is usually, or alkanol, or ethanol, specifically, usually formulated in the laboratory using fermentation. We are always familiar with fermentation. Fermentation is not a word. It's a word that we hear every day. Whenever you are at home, you hear fermentation. The ladies do fermentations by maybe drying the grains for a long period of time. You cover it. You allow it to ferment more than 3 to 4 days. That's what we call fermentation. And this fermentation is an ancient way of preserving food for more than millions of years ago. This fermentation is an ancient way. It's used specifically in nutrition and dietetics, where it's being used to preserve food for a long period of time, even from the discovery of science. That's what we call fermentation. The fermentation is defined as a scientific method of production of ethanol or production of a compound of carbon, specifically using enzymes, which is yeast. And yeast, botanical name of yeast is called Saccharomyces cerevisiae. That's the botanical name of yeast. So the fermentation specifically, it has 3 stages. The first stage, you have your starch. When you have your starch plus water molecules under the enzymes called diastase, it's going to convert into what we call maltose. It will convert to maltose respectively. So when you have the maltose, you bring the maltose here, which is the stage 2. The maltose. Remember, maltose is disaccharide, which is made up of 2 glucose units joined together by alpha 1,4-glycosidic linkage. Then we have the maltose plus N2. When you are going to have an enzymes called maltase. When you react maltase to this, we are going to form a compound called what? Glucose. When you have the glucose, which is the third steps, glucose, remember, is a monosaccharide. When you have enzymes called yeast or zymes, which is also called Saccharomyces cerevisiae, it will break down the glucose under the absence of oxygen. That is anaerobic condition. It will break down glucose to form ethanol. That's C2H5. We have the ethanol plus the CO2, which is carbon dioxide. Carbon dioxide, as the case may be. And this is what we refer as fermentation. And this is the process of production of ethanol in the laboratory or in industries. Usually, ethanol is usually produced in a larger quantity using a fermentation. They usually use the starch, specifically, to produce the ethanol. What happens is that the starch, which is the polysaccharide, will undergo hydrolysis with water, and enzymes called diastase will be added to form maltose, which is the monosaccharide, which is consists of 2 glucose linked together by alpha 1,4-glycosidic linkage. We have the maltose, presence of water, hydrolyzed, and the maltase is an enzyme that will hydrolyze the maltose to form glucose. And glucose is monosaccharide, which is what we call reducing. Then glucose specifically will undergo zymes under anaerobic condition, that's the absence of oxygen. We are going to form ethanol as well as carbon dioxide will be produced. So let's now write the chemical equation of this. If we have the C, we have the C12, we have the H10, we have the oxygen, we have H12, then we have the oxygen 5 is 6. Under this N plus water, under the diastase, we are going to have the C12 H22O11, which is our maltose. You bring the maltose down here, we have C2 H22 oxygen 11 plus the NH water and the enzyme is called maltase. We are going to have C6 H12O6. This is the glucose respectively. And the glucose will come here, we have the C6H6, C6H12O6 under the presence of enzyme called zymes. We break down the glucose to form C2H5OH plus CO2 is produced. And how the equation will be balanced? The equation is perfectly balanced. This is C6 and we have C2 here. And we have this 2 here. So automatically it's not balanced. To balance this, you add 2 here. C2, 2 times 2, 4. Carbon is 4 here. Just add 2 here. 2 times 2, 4. 2 here, 6. Carbon is 6. Hydrogen here is all 12. If you have this, 2 times 5 is 10. Plus this 2, because this 2 is attacking, we have 12. Hydrogen is 12. And oxygen is 6. We have what here? We have 2 here. 2 times 2, 4, plus 2, 6. This is how the reaction is balanced, and this is what we call fermentation reactions. At this, I would like to stop here.